Welcome everyone to one more OpenCVismo Talks. This time we have very special guests. We receive here Rob Lind and Madhu Gade. Thank you, Madhu and Rob, for joining this podcast. And I'm Natalia, your host, and now I open the space to Rob and Madhu present themselves. Please go ahead.
Okay, I'll kick off. So good afternoon, good morning, wherever you are. My name's Rob Lind. I'm based in the UK, just west of London, near Windsor Castle. I've been with Syngenta 30 years, a long time. I started as a student. I'm an insect biologist by background, but quickly got into computer vision at the turn of the century, so a long time ago, where deep learning, AI was just a dream and it wasn't really in existence. And so I grew up with traditional image analysis, and then 2012 the world changed, and that's really when I started getting into deep learning and AI. Also lead up the image analysis network in Syngenta, trying to harmonize and unite everybody working in computer vision. And spent most of my career in R&D for crop protection, and then about 3 years ago moved over to Syngenta Digital in computational agronomy to focus on growers and farmers as my customers. I'm also a Syngenta fellow as well. Okay, I'll pass it over to Madhu to introduce himself.
Hello everyone. So myself Madhu Gade. I'm based here in Switzerland. I have 20 years of experience in IT and digital space. So for the last 13 years, I'm based here in Switzerland. I'm currently working as a senior platform specialist at Syngenta. So I'm currently managing a computer vision platform. Before coming to Switzerland, I was working in the UK and also US, and I started my career in India. So I'm a little bit new to computer vision, but even though I have a personal experience with some computer vision applications, that's all about myself. Natalia, you're on mute.
Oh, I'm sorry. So I was saying that it is interesting because we have a lot of experience here from Rob and Madhu. Um, you mentioned, Rob, that you've seen things changing in 2012, right? This is the year I started in the college. I started in university. I was starting to learn things, so it's very interesting. So let's get a bit deep in your educational background. We can start with Rob, and after that Madhu. So where do you where have you studied, Rob? Can you talk about a bit about the university and the course?
So my bachelor's degree was in applied biology. This was at the University of Bath in the UK, and it was a 4-year course. And in the third year, you did 2 industrial placements, and one of those placements was at Gillett's Hill, where I still work today, for Syngenta. And that's really how I got into Syngenta. It was being a student there. So I was there for six months, learning all about insecticide screening at that time. So counting lots of insects down a microscope, and I was, even at this point in my career, I was thinking there must be a better way than counting insects down a microscope all day. And that really then triggered, I really wanted to do a PhD, and this then triggered Syngenta, or it was actually Zeneca at the time, to sponsor me. So I was a sponsored PhD student to get my doctorate, and that again was the University of Bath. So that was another sort of 3 years, and then I was fortunate enough after my completing my PhD that then Zeneca offered me a job to head up insecticide screening. But it was, I think, one of the key moments in my career really was in my PhD, where another student at the University of Bath was using computer vision to study insects, and this is really what triggered me the insight to say, right, we can bring this technology into Syngenta. So again, it's serendipity and luck sometimes in your career, who you meet and who you work alongside. So that's really how I got into computer vision. And actually, the chap that I worked with at the University of Bath, we actually employed him as a consultant to help write all the software and get the hardware sorted to bring computer vision to life in Syngenta. Later on in my career, I also did a master's in applied toxicology as well. Again, that was sponsored by Syngenta later on. So that's my kind of academic background.
This is really impressive. So you mentioned that computer vision made an entrance in your career during the PhD.
Yes.
Uh,
Yeah,
in your
it was.
work with insects.
Yeah, I wasn't using it in my PhD. My PhD was very biochemical, so it was all understanding. Well, funnily enough, it was understanding neuropharmacology, so starting to look at insect brains. And I can tell you now that an insect brain is made up of lots of distinct layers, just like a neural network, in computing. So again, the parallels there are uncanny, really, that it was a big interest in insect brains and nervous systems, and it's amazing how similar they are in lots of ways to the artificial neural networks we work on in computers.
Nice. Yeah. So, Madhu, that was about your background and when computer vision made an entrance in your life.
Yeah,
Please.
sure. So started I grew up in India, and I did a bachelor's in computer science. And even before doing my bachelor's in computer science, I did a diploma in computer science. So I have all of my education is in computer science. So when I started my job in 2023, I started with a telecom company, and also a telecom company, but I was on the IT side of things. And then later I moved to UK, and now I'm here. So most of the time I was working with the data. So in Switzerland, when it comes to education, I did masters as well in business information systems. So my computer vision experience, in a way, it started actually almost when I was working here in Basel for another company, a healthcare company. So they were developing an app for the blind, partially blind people. So if you use that app, it will tell you, what is that object. So this was the app they were developing. So I was not directly involved. One of my colleagues sitting next to me, he was actually involved into the project. He asked me to, can you test it? So I was doing the testing, and I think I find it, very useful for the blind people, that use case. But I was, to be honest, I was not knowing all those terminologies. Now I know. Now I can relate, like the object detection, model training, and all those things I was not knowing. I was simply doing it. I know there is a technology. So that was my one of the initial experience. And later on, I think almost 3 years back, I bought Tesla car, and how Tesla works. It is with a lot of cameras and a lot of computer vision technology is built in. So that is how I experienced, personally. And now I started, when I started working with Syngenta 3 years back, I worked with data. So sometime, I also worked with image data. So last year I transitioned to a computer vision department. I'm working closely with Rob. So that is where, even more interesting, and I can see a lot of use cases in our agriculture industry, and I can see a great potential, in computer vision. Even not only in agriculture, I can also see in our day-to-day life. I can see when I walk and when I go to any store, I can already see a lot of opportunities to utilize this computer vision, technology to make things better. Yeah.
Yeah. Thank you, Madhu. Um, your experience is valuable for us because in our community, for example, we encourage people not to talk just about computer vision, because at the end our models, our AIs, it
Mm.
needs to run in somewhere, you know
Yeah. Yeah.
so we need also the DevOps and people from pure computer science.
Mm.
Our community is not closed specifically to computer vision. We can
Mm.
discuss any subjects. There is a lot of people with different experiences, and together we can bring these projects to the world. You know.
Mhm. Mhm.
So yeah, let's go forward. So yeah, it's a wonderful background you two have, but what made you pursue these subject? What motivated you to? Oh, I will start studying biology. How these ideas come in your mind, and what motivated you to do it?
Yeah, maybe I'll kick off. So when I was young, seems a long time ago now, but growing up in the 1970s, I'll say that much. And I had three big passions in life. One was insects. I absolutely love insects, so that's hence the biology or being an entomologist. The other one was photography, and obviously in 1970 digital cameras weren't really mainstream back then. It was all film. And then the third thing I was really interested in was computing. My dad he was a lecturer at the local university and would bring home computers in the 1970s, and we were the only person in my village to have a computer at home. Doesn't seem possible now, does it? But and so people used to come round our house to look at the computer, not even do anything with it, but just physically look at this thing. And so I learned to program at a very early age, and I love photography and I loved insects. Biology won out at university. That's why I went to study biology, but I never lost the passion for the other two subjects. And I guess with digital cameras coming along, computing, getting faster, my three hobbies kind of came together, which is what I do now as a job. So and I guess biology is a bit wider than just insects. So particularly crops and plants, I enjoy doing as well. So that's really my motivation. That's why I'm sat here today doing computer vision R&D.
Nice. And about you, Madhu, what made you
Yeah.
oh my God, I need to study computer science.
No, I think, I mean, anyway, I mean, if you look at computer vision, right, also, right, it's also a subset of all this computer science related, field, right? So to me, right, so I started after my 10th, I started my diploma in 1997. So those days, actually, to get into computer science, and definitely you need to be on top. So, I mean, I was doing well, and, that is how I entered into it. But later on, I like maths. So, I mean, people with maths background, I think, Natalia, and, how it is helpful in writing programs, right? So I was liking programs and I was writing programs. So started with, I learned many languages, starting from even Pascal, even some other languages like Proton, and I mean C, C++ anyway. So I think mainly the interest in maths actually helped me to, create more interest in programming. And then later on, when I learned more about what kind of value that technology can bring in, right? So that is something is really, motivating me. So when it comes to computer vision, definitely it's opening up even more, lot of opportunities into any field. Mm. So just to give you an example, maybe a funny one. So when I'm walking into the store, right, normally, I think, the butter croissants, right? You have a lot of croissants. Every product you can scan, but when it comes to these croissants, you cannot scan. You need to go and choose the specific one, right? I was thinking of, why can't we have, scanner? it will detect, these kind of simple things. It can solve, many people, and otherwise they have to go through a lot of menu.
True.
So I'm giving you completely different, because I see great value in many other industries, not only in agriculture, with the computer vision.
Yeah, that's nice. So, yeah, let's get a bit more information on this subject. During your journey, your academic journey, do you I mean, did you have some experience? Okay, Rob give us the spoiler. He got to know computer vision during a PhD with a student. But every time we have some kind of mentor, for example, that encourage us to pursue some subject, some you know something. Did you have this kind of mentor, this kind of person who encouraged you? Can you tell about this?
Yeah, I guess my great mentor really was my PhD supervisor. He also looked after me, my undergraduate, because they were both at Bath University. So that's Professor Stuart Reynolds, and yeah, he was a great inspiration and still is. And I'm delighted that I'm running a conference this year on AI in entomology, and he's going to be there in the audience. And I think it's my first time of speaking in front of him, so slightly nerve-wracking, but no. So yeah, no, he's always been a great coach to me, and just the way he went about research, just about being very methodical, really thinking things through and being pragmatic about things as well. I think that's a mindset that I've really taken from him, to be very pragmatic in what I do and try and deliver always tangible things as well, so I can get my hands on things. So I think, yeah, he's rubbed off on me in a lot of ways. So that would be my sort of great mentor.
And about you, Madhu?
So there are two answers to you, Natalia. Currently, Rob is my mentor. He's a Syngenta fellow. Who else is the best person to be a mentor for this computer vision field? So, and coming back to, in my studies, I did bachelor's here in Switzerland. During that studies, we used to do a lot of presentations on how Google is investing and other companies are investing, and a lot of interest on what's going on in the current market. So my dean of that university is actually very close to me, and still in touch with him. So in a way that I can say that he was my mentor. Now the current mentor is Rob, and especially in this field. Yeah.
That it's interesting what you just said, Madhu, because it's true. We just, I think, each step, each phase of our life, we change the mentors, right?
Mm.
For example, I started my studies pretty young. I was a 15, and I started a short duration course, and there was teachers who encouraged me a lot to pursue the area where I started. I used it to be a surveyor, uh, and during my masters, I knew computer vision, and it was 6 or 7 years ago, not so long as you, but yeah. And there was a lot of teachers in my life who encouraged me and give some advice. And yeah, I can also see Rob as a mentor today.
Thanks.
Yeah. So yeah, let's proceed. Okay. And about your professional experience, could you tell a bit about the projects that you've been working on, the interests you have in your job, and so on?
Yeah, sure. So my first sort of role at Syngenta really was leading up the insecticide screening. And one of the things I immediately did was move away from human assessment to computer vision. So and that meant redesigning screens so there were camera-friendly receptacles where the insects were, so we could see through them with a camera, so like a clear lid. So that took a lot of doing actually, and statistical analysis to making sure the assessments were still good, and writing all the software and the hardware. So that was a big project really in those early days here at Syngenta. I guess then, throughout the career, I've then been involved in setting up a lot of hardware for computer vision to do lots of lab assessments. So everything from, looking at plant roots, germination of seedlings, more insect assays, disease control, fungus on leaves. So I've done an awful lot of different applications of computer vision, most of them with, RGB cameras, but we have looked at more exotic cameras too, things like microwave imaging, for example. So that's really given me a great breadth of experience there. In terms of sort of other projects, so a lot on sort of automation of imaging as well. So getting away from people swapping things around manually, but using robots to swap materials around that are going to be imaged. And also more latterly, working in the field. So how do we do field imaging? And that could be from satellites, from drones, from a tractor, from a mobile phone. So it's really understanding, what can you get out of these different platforms, and how do you do the computer vision? So that's the kind of, I guess, the practical implementation of computer vision. The other sort of side of things I've been learning or in projects is a lot about deep learning. So particularly in the last 10 years, and to help me, I've had some postdoctoral students at UK universities, really to help me understand what can you get from deep learning, how to best deploy it. And rather more recently, it's all about synthetic imagery. So how do we generate that synthetic imagery? It's going to help train the models even better, and that's been quite a journey as well, to understand what's important in synthetic images to make them worthwhile and make them usable. So quite a range of stuff, Natalia, but hopefully that gives you some idea.
Yeah. From your first professional experience, any lesson you got from there that you
Yeah,
keep it till
don't
nowadays?
yeah, don't give up. It can sometimes, something looks fairly simple, but it can be quite challenging, and don't give up. Back in, I think it was 1999 when I first got my hands on a digital camera, as it was then. It was 0.3 megapixel color. It was color, but it was hard. The processing powers weren't what they are now. I think we were using the equivalent of Raspberry Pi back then, and it was very challenging. But we didn't give up, and we did get things working eventually for doing the screening. And the other thing I would say is sort of learnings is be pragmatic and keep your end goal in focus all the time. What is it you're trying to create? What is it you're trying to do? And don't lose sight of that. It's very easy to get scope creep, or and start going off in different directions, but always think about what the end user really needs and wants, and make sure your project delivers that. So there you go. That's some of my key insights.
Yeah. And about you, Madhu, could you tell us a bit about your first experience, the lessons you get from there? Please go
Hmm.
on.
Yeah, I think it's a great question. So I think, like Rob said, I mean, the important thing for me also, the what I learned is the value that we are going to create for the business. I think that clarity is really important. So yeah, how hard we are working is, I think it all nailed it down to what value we are adding. So thinking from customer standpoint is really important. That matters. So what we develop, what we build, I think we really need to see from the customer standpoint, customer centric, thinking. Is it really needed? Is it really helpful? So that kind of thinking will definitely, we need. to ask ourselves. That's something I can say it's a great learning. And the second thing is what I see is a collaboration. Like no, I mean, I see a great value in collaborating with people, and so we can learn a lot and we can help each other, and I think we can do wonders, with collaborations. So coming to the experience that you asked, right now I'm really interested in one of the project that I'm working is biodiversity. Identifying biodiversity. So the reason I'm mentioning is we are working with research labs to collect those images, right? Number one. And we are also working with annotation companies to annotate these images. We are working with universities to train these train the models using these images, and then ultimately we are going to have an end solution as a mobile app to have this solution deployed, the model deployed. So right now I'm working on this project along with Rob. Yeah, this is something is really I'm interested in. There are a lot of things interesting in this field. It's really hard to say one thing. Yeah.
Just picking up on your point, Madhu, about teams with different skill sets. I think that's another strength you should always play to, is have a team with diverse skills, because the computer scientists can't do it all at all. You need the mixture of biologists in there and other people to make projects work.
Yeah. Just to add some histories to that question, I remember my first professional experience. I came from an academic environment, and when I started working for a company, the first main difference I saw was about the a totally uncontrolled environment. While in academy we have very controlled experiments, beautiful images, a black background and so on. in 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 the in the companies we receive all kind of images with all kind of backgrounds, and it's really hard. It can be really hard to work on these images, but yeah, is this is the beauty of the job, right? we we get used to it.
Yeah, I think that you touched on some good points, Natalia. When I was in R&D in the labs, we could control the lighting, blue backgrounds, just like Hollywood, consistent scale. Everything was very consistent. And when we were doing traditional image analysis, this is before AI and deep learning, that was really important to get good results. But now, you go in the field and, it could be sunny, cloudy, raining in terms of the lighting. Your camera angle is different. Your scale of your image is different. It's very challenging in the field. And that's when the deep learning and the AI really come in to help solve some of these challenges to make the impossible possible.
Yeah, that's right. So I think you in truth gave us some spoiler about it too, but I will ask it anyways. Who knows? We can get a new insight. Um, your journey about your journey in computer vision and that data science. Um, when have you started learning or hearing about it? For example, I heard about data science in 1218. It was the first time I heard about this subject, and I was like, hmm, this is looks pretty interesting. How when have you heard about it?
Yeah, it's a really good question, actually. So I guess I go kind of back to the 1970s when I used to program in BASIC. And one of the things that used to fascinate me was creating my own little pictures, laying down the pixels, black or white pixels, because there wasn't color screens back then. It was it was just monotone kind of monitors. And so that really got me started about controlling pixels. I used to find that absolutely fascinating that you could do that. But really, I had to wait until I'm trying to think. I then switched to Macintosh computers in the 1980s, And one of the applications that I could get hold of was called NIH Image, and that's for the National Institute of Health. So this is the US sort of health service, I guess. And they made a package for doing image analysis. And I found this absolutely fascinating, that there was this packet you could run filters on images and, you know, change images. And that's really what triggered me, you know, on the software side. And of course, NIH Image on the Mac then became ImageJ on the PC. And that's why I still today do a lot of my programming in ImageJ and Java, because of learning NIH Image back in the 80s. So that's, and obviously other things have come along, you know, since then. You know, Python was invented and all these other languages. But so I guess ImageJ or NIH Image were the sparks that really got me into computer vision.
I'm muted again. I'm sorry. Really nice, Rob. And Madhu, please. When have you heard about data science and computer vision first time?
Yeah, I mean, it's hard to say when, because, you know, it was maybe definitely 10 years back, you know, the data science was, you know, hearing a lot of use cases in different things, even the company where I was working. So I was actually initially, those days, I was working with the data, but mainly on the, you know, descriptive analytics. I mean, less predictive analytics, right? So, and then, you know, data science comes into picture, you know, with this, you know, predictive, prescriptive analytics, right? So then I used to, you know, see in the organization there are some teams in data science working on some of these things. I would say maybe 10 years back I was hearing, and then slowly, you know, I was into the data science area also.
Yeah. So that's interesting. As I said, I have heard about data science by 2018, and
Mm-hmm.
I was like, oh, this is pretty interesting. But when I was a student, I didn't like statistics. You know, in truth, I hated statistics. I found it so confusing. And when I heard about data scientists, okay, let's give it a chance. And at the end, I just love it because I think it was just my experience, you know, my mind, and on that time was not ready for it. And after studying on my own, uh, it, my mind changed, and I had a new vision about data science, statistics, and today I love it. You know, very interesting.
I think the other big driver, really, certainly over the course of my career, has been the advent of the internet. I know that sounds like everyone knows what the internet is now, but it was only really coming into force when I was doing my degree. And I can remember logging onto the internet for the first time and trying to download a picture. And I think it took like half an hour to download a very simple picture because the bandwidth was so lousy back then. And
I could remember, yeah, those
but, you
days.
know, in terms of data science, you know, downloading big data sets, getting access to the data is so easy now. Whereas before the internet, it was really hard to get hold of stuff, you know, onto your computer, to transfer stuff around on floppy disks, as it was there, you know, that had 1.44 megabytes of space. It just wasn't a lot. And so it was quite hard work, I guess, to work with big data sets, and the compute power wasn't there. But now with the cloud, the internet, it's so much amenable for dealing with big data or big data sets or lots of images in our case. So I think that's been a big driver, really, to make it possible.
Yeah, that's right. So, how do you, talking about all these changes, you mentioned the internet, the cloud, and the storage devices. Uh, how do you feel about your educational background? Do you feel this background prepared you to what is happening, or no? How do you feel about it?
Yeah, it's a good question. I just think the pace of change these last few years is getting faster and faster and faster. You think about the world changed when GPT came out, and it was only 18 months ago, something like that. And I think we drifted through that period of time, and I think the history books will mark what happened 18 months ago as quite a point in history, and yet we've just all drifted into it. And I just see, the size of the models and the compute power to compute them is obviously, pretty astronomical compared to anything in the past. But I feel, my academic career didn't prepare me for any of this because it wasn't invented yet. And I'm quite excited to see where this technology is in 5 or 10 years time, where what we're doing now will seem quite rudimentary and quite simple, I'm sure, compared to what's going to come over the hill. So I think we're living in a very exciting time at the moment, and it's hard to prepare yourself, I think, for what will happen next. And even in computer vision, 2012, when the ImageNet challenge was smashed by AlexNet, to outperform other ways of saying what's in this image, that was quite a moment. That was using convolutional neural networks, or CNNs. And now the transformers have come along, like Chat GPT is based on, and things like stable diffusion. So new things are coming along, different ways of doing things. And I'm excited about what the next big way of doing things is, what's after transformers and CNNs, for example. So I think we've got a lot more to come. It's going to be a very exciting space.
Yeah, and about you, Madhu, how do you feel about your background and the recent changes can
Yeah.
observe now?
Yeah, sure. So I think my education background, I think all of my education background in computer science, definitely it helped me up to some extent, some foundational, still we need to have some knowledge like the infrastructure side and, basic technologies. So even the programming language is changing, but still remains, more or less, the logics are more or less same. You can relate. Like Rob said, the pace is changed now. The whatever we learned from the education, it is helping as a little bit as a foundation. It's just sets foundation, but from there, I think it's everyday learning, yeah, experience.
Yeah, just to add some point, I really feel just like you, uh, because when I was a student, many things that I used to work today didn't exist, and I was a student 10 years ago. You know,
It's like I always,
so
yeah, it's like I always tell my children, they say, what am I going to be when I grow up? And I said, well, your job is probably not being invented yet. So don't worry about it.
that's right. Yeah, that's right. Things are quickly
Yeah,
changing.
Yeah.
yeah. Just imagine, I mean, even when I started in initial days, right? That is something I can remember now. We were not having like Google or something to, search for a code or something. We have to write on our own, right? So now at least, you have internet, Google, Chat GPT. There are a lot of things. You just need to know what you want, and
Yeah.
and the rest will follow. Yeah. Mhm.
Yeah.
Yeah, talking about ChatGPT, I just remember that in my student time, we made a lot of things to study. We used it to build drafts of the content so we could easily remember to the exams. And I use it to build also mental maps. Is this the you know the the draws for the content, mental maps? Do you know mental maps? Makes sense?
Yeah.
They exist? Okay. So one day I was talking to a colleague and she said me, "Oh, it's funny these mental maps, but we still need to build it. We must still to build it. We must still get the content and read all the content and select the best content to put it there. I desire that could exist something that make this job for us. Get the content, help us to select the content." And I was like, "Oh, this would be nice." And now we have ChatGPT who help us to get the content, organize it.
Yeah.
Of course, it will not do the job for us. We still need to revise, and so on. But it's a great tool to get some work done.
Yeah, and I think it's
Yeah,
only going to get better. I still think there's a long road to go with
yeah,
AI, and at the moment it's very good at regurgitating what it knows about, but it's not really insightful yet. And I think we're going to see some big changes. Will it become insightful in the next few years? And that will be a big game changer for me.
yeah. So of course, we know that computer vision and data science are very embracing fields, and I think they will be changing a bit more in the next years. But what is your favorite part of it now? What part of computer vision do you enjoy most? For example, I like photogrammetry. I like the math that relate um, one object on image and the real object in the real world. What is your favorite part of computer vision and data science?
I think for me at the moment, things change, but I'm really enjoying the synthetic imagery. So there's a bold prediction out there that says by 2030 most data sets will be mostly made of synthetic data compared to real data, because real data, real photographs of things to train neural models can be quite hard to come by. It's some industries are easy and others, like in ag, can be quite hard. So how can you bolster your training sets with synthetic imagery? And what we're finding, in synthetic imagery, there's lots of bad ways of creating synthetic images to train models, but we're trying to find what are the good ways of making these synthetic images to make models train that are robust and generalizable. And so it's quite a challenge in this area, but it's probably one of my favorite areas at the moment, just because it's quite up and coming, and it's still got quite a long way before we're really good at doing it. Yeah, so that would be mine.
Yeah, and about you, Madhu, what your main interest in computer vision, the areas you enjoy the most?
I think what is really excites me, the kind of possibilities that we have right now with computer vision to, which we could not think earlier. So I think especially these are all coming with this building model. So this is the key right now. We are still in evolution phase, right? This AI thing is evolving. So building some good models is something is really interesting to me. So that eventually is saving a lot of time for our R&D teams. So they can save a lot of time with this, with these new models that we are building. So this is something I'm really curious about it. So at some point we will have some lot of things that we are doing right now. It will become a foundational models. It will be available, but right now it is not the case. That's what I'm realizing. Yeah.
Yeah, this is a very important job in truth. Yeah. So, yeah. And about the recent innovations, do you have any particular preferred recent innovation in computer vision that you keeping your eyes on, or you already studying? What do you say, Rob?
Yeah, so that's a good question. I guess there is all the stuff around synthetic imagery, what's new there. But I guess what I'm keeping my eye out for is, what's next after Transformers, or is it Transformers are the thing? That's the big question, really. Just like CNNs or convolutional neural networks were back in 2012, they were the big things, and everyone was thinking, well, it can't get any better than this, can it? And then Transformers come along, which in some ways are better just because they're bigger and also the way they work. But what's next? So that's what I'm keeping a close eye on, really. And I guess the other thing I'd like to keep a close eye on is how are people tackling some of the real challenges in computer vision, particularly when images are very unstructured, they're taken outdoors, like the automotive industry, for driverless cars. That's quite an unstructured environment. How are they coping with that? And agriculture is a very unstructured environment as well. You never know what you're going to find in the field, and it's difficult to train a model to recognize every eventuality that might happen in the field. So I guess those are the two things really that I keep a close watch on. Yeah.
So, and about you, Madhu?
So
Any?
I'm in actually early stage in computer vision, but I am really interested in. But what I see is, I think this computer vision, even in agriculture right now, we are working right now, right? I think I see a great opportunity to evolve into a lot of other areas. So I think we are touching only few. So that's what I actually see as the next thing. I think this will evolve into many more areas, and a lot of use cases will emerge in coming months. So that is what is I'm actually really interested and to hear from our customers to see where we can automate and simplify things using this computer vision technology.
Nice. And in my case, I keep my eyes on self-localization and mapping. I think this can be promising in the future for agriculture and so on, using small robots or drones yeah. And I particularly like the technologies involved to make it work. That is a lot of computer vision, depth estimation, AI, and so on. Yeah. Um, okay. Let's talk about good things. Do you have any memorable success history or breakthrough moment in your work in computer vision or any other subject?
Gosh, that's a good question, isn't it?
There is many success, right, Rob?
Yeah,
Hard
I
to pick
think
one.
yeah, I, I think one of the big successes, I remember it was just because it was a lot of work. We tried to automate one of the one of the big lab screening projects in the company, and I think it took us maybe a year and a half. We started from scratch. We built all the hardware ourselves, all the software. You know, in that moment of finally bringing it all together and seeing the users use it for the first time, you know, to automate screen evaluation basically was a big moment really, and it was just really nice to see people using, you know, computer vision. You know, we wrote a very nice GUI, for example, so there was no user manual even written. You know, it was all very intuitive, and people just took to it immediately and never looked back. You know, didn't do the manual assessment anymore. I think that was probably a big breakthrough moment to think if you do it a computer vision project right, you know, talking about some of those things earlier, you know, keeping focus and don't give up, and you know, and when you actually make it, it was a great feeling of pride. And that system was implemented, I think it was about 10 years ago, and it's still used today. So that, you know, it's a source of pride really, that one for me.
And about you, Madhu?
So
Any
the one,
memorable success?
I think the one actually I visited a couple of weeks back. I visited our Syngenta site in Stein. Actually, you know, it's a seed care institute. So they are using computer vision for germination evaluation. This is something is really interesting. Even though, you know, that model is deployed in our platform, but I think it's a great opportunity to see how it is used on the field, you know, to accelerate the germination evaluation process. So it's actually reduced almost 10 times less time. Actually, there, you know, it is going to take to evaluate the efficacy of the seed treatment of those seeds. So using this computer vision technology. So this is something is a recent one. Actually, it's really interesting. Yeah.
Yeah, that's nice.
Just going back in time, I think one of my biggest wow moments in my career was seeing a drone for the first time. So I was
Uh-huh.
involved in some of the first drones in Syngenta back in 2012, where we
Oh.
brought our first drone and started using it, and it really kind of blew me away that we could get aerial images of fields very rapidly. And you know, the stitching software to put all the images together was just about getting there, and it was hard work for computers back then, as you can imagine. But they could do it within about 12 hours of whirring away to put these stitched images of these fields. But I could see the potential in that, and it really was a big wow moment seeing my first sort of drone flight and looking at the data coming back.
Yeah, this is nice. I also remember the first time I saw a drone, and of course, it was 7 or 8 years ago during my master degree, but it was an awesome experience.
Yeah.
Yeah. So, yeah. Um, what are some common misconceptions people have about computer vision? Um, of course, for example, I see a lot of people thinking that computer vision and AI systems will solve all of our problems. People think, oh, the AIs will solve all humanity problems, we will not working anymore, and things like this. Do you see some misconceptions about computer vision and AI?
Yeah, I think you make some good points. I think a lot of people are quite nervous about AI taking their jobs away. Well, I've never seen AI taking anyone's job away, nor computer vision. So I think that's a big misconception. And actually, a lot of the tasks that we're using computer vision for in the company are tasks that are, taking people's time away when they could be doing much better things with their time, as, having insight and doing those things a human can only do. And particularly making assessments more objective, or non-subjective, sorry, and more quantitative, so it can bring real value. So I think that is a misconception, that it will take our jobs away. I think the one you touched on as well, Natalia, is a good one, that is not sometimes easy to implement computer vision. You really have to have a little bit of background knowledge, knowing what's under the hood, how it works, really, to get the best from the technology. And even things like taking quality images for for training sets and things. So that's it's very important. I think perhaps another misconception the other way around is that computer vision must be hard to program. You have to write lines and lines of code. Well, that's going out the window, I would say. So there's a lot of no code environments, web environments, where you can string pipelines together to get things working very quickly and easily, based on some of these huge models that are coming out from OpenAI or Facebook. So I think that world is changing quite rapidly as well. So you don't need to be your nose in the code. You can do a no code way of using computer vision now.
And about you, Madhu, have you seen some
Yeah.
misconception about AI, computer vision?
So I think, I mean, in general, when you say computer vision, in a normal world, people will think mostly, if you see all the security, solutions and all they were using, they were early adopters, right? So now that is changing. The computer vision is not only for security or surveillance, right? I think this is not only for that. There are a lot of use cases actually evolving around. I think now all industries are actually recognizing and getting into it. This is something is changing. And one thing is, like, when you say any solution in computer vision, I think maybe many people may not think the importance of the quality of the data that they need upfront to train those models. So without that, I think you cannot have a solution, computer vision solution.
Yeah, um, I see. I see computer vision and AI as our main assistants. They will not replace us. They will help us a lot. They will improve the way we work, the way we solve problems. So this is what I see for the future. And okay, how do you stay updated with the latest advancements in computer vision in your field? The things you like, how you get the new fresh content about computer vision.
Yeah, very good question. It's sometimes hard. I mean, social media like LinkedIn, often I see some interesting articles on there. People are displaying their latest and greatest, so that's quite good. There's another good sort of websites out there. Papers with Code is quite a good one, so you can look up to see what the latest innovations are. And then internally in Syngenta, we have a series of technical tech sessions where people come along and either talk about a paper or the latest research they've done, and I find that very useful to hear from colleagues, both internal and external. We get external companies along to talk as well about what's the latest and greatest in computer vision. But you're right, I think it's for a multi-channel approach that I try and keep up to date with what's going on out there in the big world. And conferences, of course, as well. Shows, conferences are often a good way of finding out what the latest is as well.
And about you, Madhu, how do you keep updated?
Yeah, I think like Rob said, I think it's a multi-channel approach, mainly networking with the people with the same field. I will definitely say it's a good thing. This happens with the conferences is one. And Rob mentioned we are already having, bi-weekly Tech DL community events. That's really a nice place to see guest lectures from all industry, industry experts. So yeah. And
Yeah.
LinkedIn is anyway there. It's a default option for all of us. Yeah.
Yeah, I totally agree. Networking is a very efficient way to keep updated. This is the reason why our community came out, and now we have 600 people, not just from Brazil, but around the world. There is
Mm-hmm.
a few people from other countries. So yeah, we are reaching the end of this conversation. But to finish, I will just ask, how do you see computer vision shaping the future of technology and society? And of course, give some tips for students and people who are starting their journey in computer vision and AI.
Gosh, a big question now. I think it will touch everybody. It will touch everyone's lives in lots of different ways. And there's certainly things like the mobile phone. Everybody knows what computer vision is because they're doing it on their phone nearly every day through different apps. So I think, yeah, it will touch your life in many ways. Driving to work, you'll be on the auto drive, at your workplace, at home. It's going to touch your life in so many ways. I guess for students and things coming through, I think, being sort of literate in computer vision or understanding the basics, things are going to change in the future as we've discussed, but really have that, as Madhu said, that foundation understanding is what I would encourage, today's students to do, to ground themselves well in computer science, computer vision, because it's all based on those common foundations. It will just be new things built on those foundations.
Yeah.
Yeah, and about you, Madhu, how do you see the future in computer vision, and
Yeah.
what is your tips?
Yeah, I think for students, definitely this is a growing field in all other industries. So for students, I think they can start with the basic understanding and they can start doing, some building models and all, right? They need not to, there are a lot of publicly available data sets available. They can use that as an opportunity and they can build on top of it. And to an extent, sometimes for students, right, it's hard to find for example, companies like Syngenta, they can also work with common problems, right, day to day. The one I said, at home also you can see something, right? You have a lot of items, you can code it, you can see how can I see, someone, if you put that phone, if you can build an app. I mean, they can choose some low hanging use cases to get an understanding of computer vision and how they can build models, and that's what the skill they need, and later they will anyway learn about industry and the use cases. Yeah. Mhm.
Yeah, thank you. It was a really nice conversation. I enjoyed a lot, but unfortunately, we are running out of time. So, thank you for joining us and sharing your experience and your vision about computer vision and IT. Um, I would like to extend this invitation. So, please feel free if you want to give some webinars and so on. We are here to share knowledge and receive everyone. Thank you, Rob. Thank you, Madhu. It was a very nice conversation.
Yes, thanks, Natalia, for having us, and it's been a real pleasure talking today.
Thank you, Natalia. It's really nice talking to you.
Thank you.